This is going to be your video for sketching sine and cosine transformations. It's going to have a lot of material here, but mostly what we're just going to do is go over examples. So make sure you pause the videos when you need to and different things like that. Okay, so let's go ahead and let's start with this. Now, I know it looks a little bit intimidating, but we're going to go over a ton of examples. We're going to take one letter at a time. And as it says there, the first thing we're going to work with is A and D. Okay, first we're going to work with A, and then we're going to work with what does the letter D represent, and then eventually examples into where you'll have both an A and a letter D there. And then after that, we're going to go to B and C and things like that. But one of the really important things you need to see here is it's basically the same equation, except for one it's sine and for the other it's cosine. So that's all we're going to do. The really nice part about it is that the A is going to serve the same function in both equations. The D is going to serve the same function in both equations. So you don't have to like memorize or try to understand two different A's. No, they're the exact same A. So the first thing we need to do is think about what are our parent functions. This is already from the other videos that you've seen. Hopefully it makes a little bit more sense, but what I'm going to do always is just make them as easy as possible. So let's go ahead and let's draw the parent functions. In order to draw the parent functions, if you remember, it's always going to be 5 points, and that's going to be what we're going to be using throughout this entire lesson. So for instance, sine. We know sine starts, here goes a really simple xy axis, okay? We know sine starts at the 0, and then it's 5 points, and it starts something like this, right? Where you go up, you go down, and then you come back right there. That's the sine. So there goes our first point. Let me just draw the points right there. So that's the 5 points that you need to draw, okay? So then the last point, and then we're going to go ahead, go up, come back down, and then there you go. Now, one really important thing is that it always goes up to 1 or it goes down to -1. That is our amplitude, our midline. So if you remember from the other videos, our midline is y equals 0, since it is technically right the middle line, which lands on the 0 part of our y-axis. Now, at this point, since if you notice the title of the video and the title of this notes, it's sketching. So we're not going to really worry about what these numbers are here in the middle, even though you already know them or you've already seen them before. The two numbers that we're going to actually worry about is where it starts and where it ends. So for instance, this is going to be, this is going to be super important. The fact that it starts at 0, and then where does it end? And if you remember, it ends at 2 pi. Sorry, that doesn't even look like a pi. So it ends at 2 pi. Okay, that's the parent functions. Parent functions always start at 0, and they go ahead and they go to 2 pi. They start repeating at 2 pi. So if you really wanted to, right, we could keep going like this, and then we keep going like that. Remember, it always peaks at 1 and goes down low to -1, because that is our amplitude. So our amplitude is going to be 1. Amplitude is never negative. Remember, it's just telling us the distance between the midline and how far away it goes. And so let's go ahead now and draw the cosine one. Same thing, 5 points. But cosine starts up at sort of 1, and then it has like sort of like this V shape. Remember, try to make it smooth right here, not a little corner. Try to make it smooth. So still is from 1 to -1. But then we start there. Notice already the difference. Sine starts at 0 and cosine starts at 1. So we're going to do our little V. And we're going to end basically at the exact same 1 line, but just further away. Notice here how I went down, and it can't go like lower than -1 when we're talking about parent functions. So then we could go ahead and, again, it starts at 0, and then this right here is 2 pi. Because we're talking about parent functions. It's really important you understand that, right? For the period, basically how long it takes to start repeating, starts at 0 and then it goes to 2 pi. So technically it takes 2 pi to repeat. So once again, if you wanted to, right, you could continue this. And technically this right here would be 4 pi, since once again it takes 2 pi to repeat. So you just go ahead and do that. But for right now, you don't really need to know that. Every time we graph, I'm only going to have you graph 1 cycle. So that's what it means. Right here, this is 2 cycles because you're basically repeating it twice. Okay, so this is really important. You have to remember this. Let me just go ahead and same thing, like midline right there, and then the amplitude is 1. So technically, this is also true for this equation right here, this graph, sorry. Everything comes from this, okay? We're always going to deal with the 5 points. That's the super important part right there. So then let's go ahead and let's move on to the first example. And you're going to see how different the graphs are going to start looking. One quick thing that I totally forgot to mention, let's look at the names. Notice how for sine, I say f of theta. This is just a very fancy way of saying the name for the equation. Okay, so if, for instance, if I were to graph this and I would say, oh, look at f, you know exactly what graph I'm looking at. And then if we go over here and we say, oh, look, g of x, I know that this graph, we're going to call it g. The fact that this has x inside and this has theta inside, it doesn't really change the fact that they're variables. The only thing it's changing is like, oh, you're plugging in values for x in g of x, where you're plugging in values for theta in f of theta. But you're still plugging in like the same numbers. You're still plugging in either radians or degrees, and it still works as a regular variable. So it's just a name. I'm gonna go ahead and go back and forth just so you can get the idea of it really not changing. It's just what variable am I deciding to use at the moment, and what's the name of the graph basically. So let's go ahead to the first example. So in the first example, we see already we're only working with a here. A is in the front, right? If you think about the equation, there's no other number, right? There's no plus anything behind it. There's nothing inside the parentheses, so no B, no C. So let's go ahead and A here is equal to 2, and then A here is equal to -2, right? But if you recall, A has to deal with amplitude. So what is that negative sign gonna do? So let's come back to that later, but for right now, let's just graph this first one. So here goes my XY axis. The fact that it's a 2 means that instead of it going from 1 to -1, now it's going to go 2 away from the midline. The midline so far, nothing has changed because there's no other number, so this is still considered to be our midline. So we still have our midline at y equals 0 because it comes from the parent function. And now I'm still going to draw my 5 points. Where it starts here, it's going to end here. But now, instead of going up to 1 and then coming back down to -1, this is the parent function. But we're not graphing the parent function anymore. We're graphing 2 sine of theta. So now it's going to go 2 away from the midline. That is extremely important you understand. It's 2 away from the midline. The midline has not changed because there's no other numbers there. So we're going to go ahead and go up to 2 now, come back down to -2, and then there you go. Remember, these points right here, it's the 5 points that help me graph sine. For right now, you don't really need to know where this lands, okay? Just think about there's no other numbers, so it's still going to be from 0 to 2 pi. The start and the end. It'll change eventually. It'll get way more harder, but for right now, this is what we're doing because we're only focusing on A first. And so now let's go ahead with this -2. What does the -2 tell us? Just like before, we're still gonna start at 0. So we don't like change for sine. We don't change where it starts. So what the negative sign does, it basically, think of it as it's going to flip the parent function. So this is the parent function, right, where it starts at 0 and then it goes up and then it comes back down. But now instead, it's going to do the opposite. So it's going to go down and then it's going to come back up. right? So this is the positive one, and this is the negative graph. So that's all that really changes. The amplitude depends on the problem as well, but it's still going to do the same thing, right? Instead of going up though, now it's going to go down, but then it's going to come back up. So that takes care of the negative sign. So let me break it up into two spots. So the negative sign is taking care because we already did that. Okay, that's what I'm going to go ahead and graph. And then the 2, all it does is it tells us instead of going 1 away, it's going to end up now going 2 away. So just like this problem over here on the left, right? Just like this problem, we're going to now go ahead and go down to -2, come back up, and then there you go. We haven't changed anything else, so this is still 2 pi, and that's still 0, and we still have our 5 points. Okay, so if ever you see a negative sign in front of either sine or cosine, all it does is it just flips it. That's all it's doing. Let's go ahead to the next example now. So first thing you notice, we're talking about cosine. So as soon as you see cosine, you know it's going to end up looking like that. Now, just like before, this is the positive one. If we want to go ahead and think about, well, what if there's a negative sign in the middle? All we're going to do is just sort of flip it. So instead of it being a V like that, it's going to be sort of like an upside down V. Okay, so that's all it does, the negative sign. So let's go ahead and now let's see what we get. So here goes my XY axis. Let's remember that we start at 1. That's like for the parent function. But now if you notice, there's a 1/2 in front of the equation now. There's a 1/2 in front of the cosine, which again takes place of the a. So a equals 1/2 here in this one. And then if we look at this one here, a is going to equal to -1/2. Okay? So let's do the one on the left first. Since a equals to 1/2, what this means now is that instead of it going up to 1/2 or instead of it going up to 1 where it usually is here, right, and then this is -1, it's now going to go 1/2 away and -1/2 away, 1/2 away on the bottom of the midline. We still haven't done anything with the midline, right? That's super important. The midline is still the x-axis. So now let's go ahead and let's graph it. It's 1/2, so that means it'll start here instead, and then it'll do our little V. Okay, remember, these are just sketches, so we still haven't done anything with the period, and then this part right here is the 0. So there you go. That would be the graph, because you're not changing anything else right now. We're only using A. Okay, so let's go ahead with the next one. Let me do my XY axis. If you notice, the A is -1/2, right? -1/2. So let's think about it. The negative sign, all it does is it basically just flips the graph. Okay, so our parent function usually goes from 1 to a -1/2, but now since we have a 1/2, it'll go just to those numbers. Our midline still hasn't changed because we don't have any other numbers. That's where like the D comes into play, or the B or the C. But for right now, all we're working with is A. So we have to think of it, when it's a -1/2, think of it as like two sections. The negative section and then the 1/2 section. The negative, all it does is that it's going to flip it. So instead of it starting at 1/2, it's going to actually start at -1/2, because we want to get this shape right here. And so then the 1/2, we already worked with it because it went 1/2 away. Okay, so you always have to think of it in two sections. So we're going to go here, do our little V, and then come back and stop. Once again, it's from 0 to 2 pi because I haven't changed anything at all. Okay, well, it doesn't look like pi at all. So boom, there you go. Okay, so that's how you would do fractions that are less than 1, right? You would just put them in the correct spot and then the negative sign again. So let's go ahead and move on to the next example. I chose these two examples because even though they're they look very basic, we tend to mess up a lot because we tend to overthink. Let's just go ahead and determine what is a equal to for this one and what is a equal to for this one. So if you notice, there's a negative sign there in the front, and there's no number, but technically there is a number. We just kind of don't decide to write it. It's technically -1 cosine of x. So a is -1 for that one. Here for the h of theta, again, there is no number, but we actually do have a number. We just decide not to write it because it's so basic. So that means a is equal to a 1, which is positive because there's no negative sign. So then let's think about how this is going to create our graphs. So let's go ahead and let's graph y. Since a is -1 and it's cosine, we know that cosine is going to be the v, but this one is positive, so I need to convert it into the -1. Sorry, that is not good. Something like that. Okay, and this one is the -1. So then let's go ahead, and that already takes place of the negative. Now let's worry about the 1. The 1 just means that that's the amplitude basically, or that's how far away it's going to be from the midline. Our midline hasn't changed. It's still the x-axis. So now let's go ahead. Cosine starts at either the 1 or the -1, depending on the problem, of course. Since this one's a -1, it'll start right here because it'll be doing this graph. And so I know it doesn't look super, on the same line, but just know it is. And then right here, this one is 2 pi. We haven't done anything. Okay, so that's how you would graph y. Now let's go ahead and let's graph h of theta. It's equal to 1. It's +1. And so therefore we would be using this one for h of theta. And so now let's think about, it's 1, so nothing really changes. It'll just basically look just like the parent function. So we go there, and then we can go ahead. And there you go. This will be my 2 pi. If we bring it back to 5 points, right? 1, 2, 3, 4, 5. I haven't been really using it, but they're there. I'm not really figuring out what those numbers are in the middle, because for right now, that's not important. That's only important if you get to other classes, okay? So that's how you would graph this one right here. So just remember, I chose these examples because they look very basic. It seems like there's no numbers, but we can go ahead and we can put a 1 if we don't see a number there, or if it's a negative, just put a -1 in the front. And so A basically works the amplitude. In a really sort of weird sense, it tells you how far away you go from the midline. Notice for all these examples, the midline highlighted in yellow is always sorry, I forgot to do this one, is always the x-axis, and I chose those very specifically because I only wanted you to see how did A work, right? How does A change basically the equation or the graph, okay? So A works the amplitude when there's no other numbers like B, C, or D. Now let's go ahead and let's start throwing in a new number there, okay? We're going to be working with D now, okay? So notice how two very important things, okay? It is outside the parentheses, and then it's either going to be a plus sign or a minus sign, and that's going to actually be very important on what it is, okay? So it has to, in order for it to be considered D, it has to be outside the parentheses, okay? And then it is separated from the sine or the cosine. If you notice, it's not together with it, as opposed to A is right next to it, A is being multiplied, but D is either being added or subtracted. So that's very important you understand that. So let's go to this right here. Let's break it up, okay? We have the thing we already have seen. A is equal to 3. It's positive, so that means sine is going to end up looking like that. Positive. We don't have to worry about the negative because it's not a -3, Okay, that's really important already, so it's going to be that. But now we have this new number here. D is equal to -1. So that gives us the new midline. So let's go ahead and let's see what happens when we try to graph right now. So same as before, I'm going to go ahead and make my XY axis. Now, you have to be a little bit smart about this. Maybe right now this isn't the really smartest XY axis, and you'll see why right now, okay? Because it's not going to give us enough space. So the first thing let's do is this new midline, okay? So it's at -1. So what that means is right here at -1 is where our sort of our like x-axis or our new x-axis, if you want really want to think about it. So this is sine. So we remember that sine has 5 dots and it goes like that, okay? And so basically it starts at the midline, and then it goes up and then below the midline, and then it goes back to the midline. So we're going to go ahead and do that, right? It always starts there. And now this is where you have to take into consideration your amplitude. So it's going to go up 3. Now it is not going to peak anymore at 3, right? Or at -3. And let's go ahead and let's really think about why this actually is happening, okay? So if you remember, amplitude is the distance between the midline and how far up it goes, right? That is how you figure out amplitude. So basically what this means is you need to go 3 away in both directions. So let me go ahead and let me try to explain how it is. So basically the peak right here, this part is going to be 3 away from the midline. So we can go ahead and we can count, right? So this is 1, this is 2, and that's 3. So it's actually going to go up to 2. That is where it's going to peak. And then if we go in the other direction from the midline, it's going to go 1, 2, 3. So it's actually going to go down to -4. Okay, so that is where you have to be very careful. So in order for us to go ahead and sketch it out, we're going to go to 2, come back down, cross the midline, and then go down only to the 4, okay? And then come back to this, right? We still are not changing anything. So we know this part right here is 2 pi. We know this is the 0 because that's where it technically is. It's starting on the y-axis. So that right there would be our graph. So it's a little bit weird to think about it, but your first step and what's going to be the most important step is going to be your midline. You need to figure that out first before you even start graphing. After you figure out midline, you're going to go ahead and determine what the amplitude is, and then really start thinking about, well, where is it going to peak now, because it changes. Because you're not counting from 0 anymore. You're counting from a different number. Some of you guys can probably figure it out, right? You can just do +3 -3 to -1, and that'll give you, but you can also count. I'm gonna really try and avoid fractions, because then you're not, it's just testing you on fractions instead of the concept. So that is how you would graph it. Let's go ahead and let's move on to the next example. And we're going to go ahead and do it the exact same way that we just did the other one. Okay, so this is your next example. We're going to do the exact same thing as before, okay? We're going to first figure out the midline. So that's actually going to be the first step. First the midline, and then we're going to figure out what the amplitude is, just to get an idea of how to sketch it and how to draw my XY axis. So the midline comes from the number that is not attached to either the cosine or the sine. It's either not attached because you're either adding it or you're subtracting it, okay? So we see here that it's 3 and that it's +3. So what that means is that the midline is going to be at +3. And then what we can just go ahead and do is think about how to draw the XY axis then. So if it's going to be shifted up 3, that's what you really need to understand. You're going to go, instead of starting like at the x-axis, you're going to go up 3 spots or 3 units. So what that means is I'm going to go ahead and draw my x-axis like that, just so I can have more room on the top. And so let's go ahead and it'll be 1, 2, 3. and that is where my new midline is going to be. So basically the graph is going to oscillate around that midline. Now we can go ahead and we can see that we're talking about cosine. So cosine is going to look like that when it is positive. But if you notice, the a, which is a number in the front being multiplied with either cosine or sine, is -2. So what that means is that we're actually going to flip this, and it's going to be like an upside down V. Okay, remember, it has to be smooth edges. You can't have sharp corners. And so then, because it is negative, this is the one we're going to use, okay? Because that's the negative one. Now, let's go ahead and we already found the shape. We already found where it's going to sort of oscillate around. Now let's think about where am I going to go ahead and start putting my points, and that's where this 2 comes from. So you have to understand, right? All it means is that it needs to be 2 spaces away. Wow, that is horrible. It needs to be 2 spaces away from the midline in either direction, okay? Because the midline technically is right there in the middle of our 2 graphs. And so what we can go ahead and do is, it's 2. We already did the negative by, knowing that this is how it's going to be graphed. So all that means is my first point, this one right here, needs to be 2 away from the midline. So if the midline is at 3, then 2 away means it's going to go 1, 2. It's going to start right there at 1. And then going in the other direction, we know it has to go up by 2 again. Ooh, sorry, that is way too. So going up in the other direction, it's going to go up by 2. So we start at 3, so that's 4, and now that's going to be 5. Okay, so what that means is that it's going to go around the midline, and it is going to, the lowest point it'll go is 1, and the highest point it'll go is 5. And so we know that by looking at how this -1 graph looks like, we're going to do something like this, where it's basically, it's very, very, it doesn't really look like it, but so let me go ahead and let's draw it one more time, just so it can look, there you go, a little bit better. Okay, because you're going the same distance above the midline and the same distance below the midline, which is 2. Once again, right, we still haven't changed it. It's still from 0 to 2 pi. Okay, so first is the midline, and then you want to think about what shape it has to be. Is it either positive or is it negative? And then you have to think about the amplitude. The negative sign, we already used it, okay, because we went ahead and we knew that it was going to be an upside down V. And then the 2, you just count from the midline. That's probably the most important part. Everything is from the midline, okay? That's why it's basically the first thing we figure out. So let's go ahead to the next example and see what we get. I already can tell some of you are probably going to be a little bit confused because of just how the equation looks, right? G of theta is equal to 5 minus cosine theta, where if we go back to the other examples, you see there it says -2 cosine of x plus 3 sine theta minus 1. It was always behind the cosine or the sine, but now it's in front of it. Don't get scared about that. All you can do, if you really want to think about it, just rewrite it so something that you can recognize. So G of theta is equal to, instead of writing the 5 first, why don't you just flip it? Negative cosine theta, and now that 5, if you notice, it doesn't have a negative sign in front, so that means it is positive. This is pretty much the same idea as saying so think of it like this, right? Think of it like saying 2 plus 5 is the same thing as saying 5 plus 2. We know the 2 is positive, and if we want to move it behind, we would just put a plus sign in front of it. The 5 is positive, so therefore we don't put a sign in front of it. So it's the same idea, right? You're just you're basically just rewriting it. For some of you, I would suggest this 100%, just because it's gonna help you out a little bit with figuring out midline, seeing which one is the amplitude, and not confusing the 2. So if you see this here, the 5, it's
separated from the cosine with the plus sign. So what that means is that this one is going to be our midline. Okay, and then we see here in the front there's a negative sign, but we could go ahead and put a little -1. So that means this here is our what's going to help us with our amplitude. Right now, I'm not going to call it amplitude because the negative sign is there. Amplitude, remember, it's always a positive number. It just tells you the distance. So let's go ahead and let's graph this. We're talking about cosine, so then we're talking about the V shape. You know that one's positive, but there's a negative in front of it, so that means I need to convert it to the negative version, which is just the opposite. Not inverse, sorry, the flipped. You can say it like that, the flipped one. And so then we go ahead and we see our midline. Well, sorry, let me circle it. We're going to use the -1 because there is a negative sign, okay? I put a little check mark next to negative just to remind myself I already worked with it. And so now what we can go ahead and do is draw our XY axis. Be smart about it. We're going to go up 5 by the positive sign. So I'm going to go ahead and draw my XY axis like that because I know I'm going to go up 5. So then let's go ahead and 1, 2, 3, 4, 5. That right there is my midline. So I'm going to draw that line right there. So it's going to oscillate around it. Remember, it's always the middle part. And so then we go ahead and we just start doing our dots. This is the first dot I'm going to draw on the graph. Since it's negative, we're going to go ahead and draw the upside down V. But since it's 1, that just means it goes 1 away in both directions, above the midline and below. So that means it's going to start right there, and then it's going to peak up to 6. And then you go ahead and draw your dot. If you notice, I really haven't been dealing at all with the x-axis because right now it's just 0 to 2 pi. Okay, once we get to the little b and the little c in our original equation, that's when we start messing with it. But for right now, there you go. This is going to be a sketch for g of theta is equal to 5 minus cosine of theta. So let's go ahead with the next slide and see what we have right there. So just to recap, A works the amplitude. Notice how I did not say A is the amplitude, okay? Because remember, A, if it's negative, it just means you have to flip it, okay? So, but you will get how far away you are from the midline from A. And then D works the midline. So D, we can say that for sure. D is the midline. The positive or negative depends on where you would draw the yellow line I've been drawing in all the examples. So really fast, let's go ahead and give yourself a quick self quiz. This is what I usually do in class anyways, okay? So try to figure out what these 4 answers are. Think of it as a mini self quiz to you. You need to get minimum 3 right for it to be considered you're passing the quiz. Now, if you get 4, that's awesome, but 3 out of 4 would give you 75%. So really try it. It's okay if you get something wrong. Just try to understand what you get wrong. And so what I'm going to go ahead and do is just put the answers. I won't explain because you can go back to the examples in the video and you can look them over. Okay, so go ahead, try it out, and see how many you can get. I know the last one looks really hard, but just really concentrate on what we know so far. We've only worked with the number outside, which gives us the midline, -1, and then the amplitude is going to be the number in front of the sine cosine being multiplied, which you can see right there, it's 4. This right here, it doesn't matter for this problem because if you notice, all I care about is amplitude and midline. We're going to get to that later, and that's where like it gets a little bit more hard, but all we care about is the amplitude and the midline. Since it's a positive sign, because it's a +4, it'll still look like that. Okay, so I hope you guys at least were able to get minimum 3 right. If you only got 2, that's fine. Try it again. Look at where you do your mistakes. Go back to the video. Look at the examples. And, you know, just keep trying, okay? The biggest thing is you need to understand your mistakes, not just get frustrated, copy down the correct answer, and then, you know, just be happy with yourself. This is where I'm going to go ahead and stop this video that talks about midline and amplitude based off of the equations. in the next video, we're going to talk about the actual, this part right here that I erased. Because honestly, figuring out this right here on the inside, it's going to be a little bit more work, but it's going to hopefully make sense for you guys. So, see you next time.